Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about the curse that gives me blood pressure of hydrogen. Why the heck people not seem to get it? So let's dive right into it. So what exactly is the dream of hydrogen? Well, the dream of hydrogen is that it gives us the benefit of fuel. Now you have to understand that while EVs are great and all, but fuel has certain advantages. For example, you can store it, you can trade it, you can use it in all formats, meaning you can use it in car, you can use it in truck, you can use it in train, you can use it in plane. You don't have to think about it. So it's quite awesome. Now here's the why can't we do it right now? Well, we don't know how to make hydrogen. All we know is like take methane, do extra steam to it, and then get steam reforming hydrogen. Basically, we are getting methane with less energy and more pollution. So at that point in time, it's just like to just run on methane. So we can't do that. Now, what about the dream? The dream is green hydrogen. What does that mean? That simply means you have hydrogen that is extracted from water. Basically, if you are old enough, you must have done this sort of experiment where you put basically one 9-volt battery, two tags, and voila, hydrogen and oxygen separated. Don't do it for long. It does make chlorine gas. So this is the idea that we're going to use water to make hydrogen. We'll no longer need to use hydrocarbon. That's awesome. Another, how the heck you're going to get the power? Because be mindful, hydrogen at this point in time is not an energy source. It's not like fuel. It's an energy carrier that acts like a fuel. So you have to provide it power, renewable power. So that's the dream, that we're going to have renewable power. We're going to have hydrogen from water, and that's it. And the best idea of this is that nations can become energy independent, because you have to understand, at this point in time, you may think India is independent. While we are also not. And be mindful, this is not just a dig at India. This is a problem with every other country. It's like they are like, hey, what if somebody else have their oil wells dry up? You will be messed up here. So this is a very serious thing, that we do not have energy independence. We are all like interdependent on each other, which is not desirable for many things. So many countries want what we call energy independence, where they are like, dude, I don't care what the hell happens to your country. It's like me taking care of my people, done. Energy independence, that can be done if this was done. And hydrogen economy is like a magic bullet solution, where there's one thing that solves us all, meaning our car no longer range anxiety, and it's just like a petrol car. You can even have like plane, jet engine, or even a combustion engine if you really want to. So that's the dream, one thing to solve them all. So is there a need for it nowadays? Because again, hydrogen is like an old technology, but new kid in the block is EVs. So why the heck we are no longer focusing on EV and focusing on hydrogen? Well, reality is EVs does have limitations. The limitations are what we call as big load. For example, for my court case, I have to travel to around 440 kilometers in one day. Would I ever trust an electric car for that? Hell no. Unless electric cars have range of like 700 to 800 kilometers, because be mindful, the range shown there versus range you get in real life, it always fluctuates too much for me to have like any known confidence. Again, if you have a charging station, still would be an issue, because again, charging in petrol pump takes few minutes. Charging in electric car station could take 1 hour if our battery is depleted to any reasonable level. So EV can't handle big loads. For example, jumbo jet. So if any Tom, Dick and Harry tells you that we're gonna make a battery that's gonna allow us to fly jumbo jets, run away from that. Like they are smoking some quality weed, I would urge you to run away. Or if there are like there's this technology that allows us to have that kind of energy density, run away from that plane. Because be mindful, these fires that happens on EVs are very brutal. Now, have you ever wondered why? Like we have petrol, we have diesel, and those things have more energy density than this puppy. Then why the heck those fire can be managed, this cannot? Well, reality is very simple. Battery is self-contained, meaning it has both part of the component. For example, if it has things that can burn, things that will allow it to burn both inside a container, meaning it's self-sustained. So when it catches on fire, all fire brigades have the instruction is just like pour on water on it for hours. Why? Well, if let's say it has 10 modules of battery, if one module catches on fire, try to keep 9 other cool, because if they catch on fire, and be mindful, if you are talking about like big truck size battery, and if it's not on normal chemistry, like let's say lithium titanate oxide system, LTO cells, if it catches on fire on lithium ion, it will put a hole in a road. That's how hot it could get. And be mindful, this is very little megajoule per kilogram. If you increase that puppy, the boom potential goes up exponentially. Now, to understand that in normal context, what has more energy, TNT that goes boom or petrol? Petrol has more energy. Then why the heck our car does not go boom? Well, oxygen supply. There is not enough oxygen, and if you have that enough oxygen, you can make rocket engine out of it. And TNT has the benefit that it has everything self-contained, so it can dump all that energy instantaneously. That's why if anybody claims that there's going to be a battery in the future that somehow breaks through, like, all our current limitation and be like 10 times more energy dense, you do not want to be near it, because it will be a miniature nuke, and I am not joking. So that's why, like, battery cannot go there, and that's assuming if that technology exists, which it does not right now. So fundamentally, it cannot do things. Jumbo jet, heavy trucks, it cannot. Container ships, hell no. Freight locomotives, nope. And hydrogen can act as a good option here. Basically, what you are doing on this is dumping energy from your grid into these, and they are doing your job. Here you will dump energy from the grid to hydrogen. Hydrogen will dump energy into these puppies, and it's going to act like a normal fuel system. So you can refuel it, because be mindful, many of the mining trucks run 24/7. Of course, their crew keeps changing, but you cannot do that with an electric system unless it has like a battery swapping system. So there are some limitations, some serious limitations. And again, jumbo jet simply cannot get off the ground. It will not have enough oomph to even get off the ground. The weight of the battery itself would be too huge. So that's the physics-based limitation. We cannot bypass it. That's why there is serious interest in hydrogen. That's like a valid reason for it. So let's come to the problem of it. And this graph is from Department of Defense. Very important graph. You have to understand, I specify things very clearly. There are 3 layers of things. You have physics, you have engineering, you have economics. Let's come to from the base layer, economics. Every hydrogen vehicle you see, be it a train, be it a plane, or a small plane specifically, a small plane, be it a train, be it a car, be it a truck or bus, all of them are electric vehicle first, meaning they have battery, they have electric drivetrain, and then instead of having a very large battery, they have a like small enough battery, and then they have a fuel cell stack, and then they add tanks. Those tanks are very complex, very expensive tanks, huge tanks. And they need new infrastructure, because be mindful, it is true for many people. That's why, like, even basic cars like Mahindra Evo is selling a lot in India. Tata EVs, they are selling a lot in India, simply because people have realized that, hey, if I have a fixed load, meaning from here to office, here to office, here to office, this sort of load, I can just charge my car at night, at home, at low power cost, without too much hassle. So we no longer need new infrastructure. We have the infrastructure. It's like, don't think too much about it. Again, fast charging needs infrastructure, but basic charging does not. And if you organize your stuff well enough, you will never ever need it, unless you are doing long road trips in those scenarios. And many people just have 2 cars, so they're like, electric is for daily bulk commute. For long range, they have fuel cars. So that's the reason why hydrogen cars can never be as cost effective as electric car. You're like, wouldn't electric car have more batteries? Here's the more of something is always cheaper than adding more stuff. For example, fuel cell, expensive, new stuff. Idiotically expensive tanks, very expensive. Plumbing, super expensive. Hydrogen infrastructure, hyper expensive. So how the heck it will be cost competitive? It won't. It will simply take money from one pocket to dump to another pocket. Basically, it will be subsidized, and you have to pay higher taxes for that. So that's just the economics layer. That's law of physics. You cannot bypass that, because again, it has to be battery driven system. Then we come to the real aspect. Every time that somebody wants to sell you hydrogen, anyone, that's how you know that somebody is trying to sell you hydrogen and they are not genuine, is they're going to tell you that hydrogen has 120 megajoule per kilogram compared to diesel's megajoule, that is like, 38. And the moment somebody says that, take a dynamite, shove it their ass. Like, flat out. We do not measure anything in kilograms. We always measure things in liters. Meaning, if you buy a car, what do you ask your dealer? Again, liters could be different. It could be gallons, whatever have you. You're going to say it's going to be 25 liters or 45 liters. If you buy a car or a bus, it's going to say 600 liters. If you buy Airbus A380, they're going to say it has 320k liters of capacity. And engineer, whoever designs it, be it container ship, be it whatever, be it a tank, it's always designed in liters. Now, why do we use tons? Again, it is easier for calculation for pilots. That's why we use it. Not for engineering. For engineering, it's always volume. Why? We live inside a world. This world have constraint, meaning your car cannot be size of a truck. That's why never measure things in kilogram. It has to be measured in liters, unless you are dealing at extremes like, a nuclear level and all that jazz. But generally we don't. So you always have to focus on liters. Now, what does that mean? That simply means, let's come to real world. Airbus A380 is a real plane, exists in real life with that kind of tank capacity. So what kind of energy you can get out of it? Jet fuel has in megajoule liters, 34 megajoule per liter. That's a lot. Now this graph has like JP8. JP8 is a variant of JP1, jet propellant 8. It's specifically used for military purposes. That's why JP1 is not there. Now, what does that mean? That simply means it has a lot of energy. What does diesel mean? Diesel has 38 basically here. It's a very high density fuel. And what does that translate to? For example, you may be like, hey, what if my car and truck does not convert 100% of it, which would be true, factual true. So assuming worst case scenario for diesel, be mindful diesels are very efficient because they have very high compression. If you're only getting 20%, only 20%, you're gonna get 7 megajoules of useful energy per liter of fuel capacity. Again, all those sounds not that great compared to like 120 megajoule per kilogram. Let's come to hydrogen. Now put some real constraint. Liquid hydrogen. That puppy only has 8 megajoule per liter. That's negligible. Like, let's be real, diesel are far more efficient than 20%. That's petrol. And at that point in time, hydrogen, because again, you cannot just hydrogen movement. You have to convert hydrogen into that. In real world, you will always find petrol, even petrol will be more efficient than that. What does that mean? That simply means if you take Toyota Mariah, it has basically hydrogen tank inside it, which is not liquid hydrogen, it is pressurized tank. So that tank volume, basically how much capacity it has is 122 liters. And because of the high pressure involved, it has to be a cylinder. It cannot be a custom shape where batteries are making it to like floors. So your car volume is exactly the same. Here you cannot do that. It will take up some useful chunk. And the pressure is 700 bar. So what does that mean? You have volume, you have pressure. How much oomph you have? 4.9 megajoules per liter. That's the part. They will tell you this, but they will never tell you this, megajoule per liter. Here's the diesel, here's the hydrogen, liquid hydrogen, here's 700 bars, here's 350 bars, which people were trying to do because again, they realize 700 bar tanks are idiotically expensive. Now, many people are not aware of like what does 700 bar means. Again, I get it. Like most of us deal in PSI, like we have some PSI in our bicycle or motor car wheels and all that jazz. LPG, liquid petroleum gas, it's a very heavy gas, generally, propane, butane, ethane, those sort of heavy boys. Those are at 3 bars. CNG, like compressed natural gas, which is methane primarily, that is only 200 bars. To give you a context how complex basically Mariah tanks are, that CNG tank is used as a bladder in 700 bar, meaning they have a metal tank that again, if it was 200 bars, that's like, bro, I got this, but it does not got it. So what you have is tank, then you wrap that puppy up in nylon, or even more expensive thing, but lighter thing is carbon fiber, and it has 1 inch thick of carbon fiber. How the heck it's gonna be cheap? So that's the problem. Anytime somebody tells you, it's like, oh, hydrogen has megajoule kilogram, take a dynamite. Be ready. Like, be ready to go to war. Just ask them what is the freaking like megajoule per liter. Your volume is always limited. You cannot be like, oh, my tank size is like 50,000 liters. And be mindful, it's like people forgot like hydrogen is the first element in the periodic table. It's the lightest thing there is. Like it flies. We use it as a lifting gas. That's how light it is. You cannot compress it. You can to get useful and then like before you get into that solid hydrogen thing, while it does exceed this basically liquid hydrogen 8 megajoule by a little bit, like it will be 9 megajoule per liter. The tank has, let's say for 10 kilograms of hydrogen, the tank weight would be 110 because it's using metal powder, metal hydride powder. So that can only be used in 2 things most likely. First, submarines, because they need a huge ballast weight. They're like, shut up and take my money. Or basically things that need those sort of heavy weights. For example, forklift trucks. Anywhere else you try that? Yeah, no. So that's why. That's the physics level problem, and economics also, I specified. Like you just don't have enough oomph on it. Meaning even if you have a plane that's running on liquid hydrogen, which, be mindful, we did it long ago. I urge you to Google like what was the first plane that tried that long ago. It simply cannot go far. It does not have enough oomph. And that's assuming, be mindful, at liquid hydrogen, at jet engine, you have to use it in combustion. You cannot have that fuel cell, then have electric motor, because be mindful, motors that are powerful enough, do they exist? Yes. But all of them are superconducting motors. You cannot put that in a plane. Again, you can, it's just like weight, cost, lol. Be mindful, ethanol is a poor fuel because again, it's an alcohol group fuel, not hydrocarbon group. Even this puppy is above 20 megajoule per liter, meaning even with ethanol, you will get farther range on locomotives, methane, methane, all that jazz. Like that's the thing that matters the most. It's like how much tank space you have to compromise. Like imagine Mariah as a normal petrol car with 122 liter of tank capacity. It will go from a country to another country before it runs out of fuel. And if it's a diesel, it's like, I never refueled it, I really should look into it. That's how big the range difference would be. Yeah, it's better than battery, but compared to combustion in real terms use, hell no. So that's the core problem with it. Now we come to the wastage part of it, and this personally boils my extra blood, because I do understand that part is hard. You have to understand that even though pilots talk in like we have this much ton fuel and all that jazz, like we don't measure things in tonnage. It's again for conversion, counting, accounting, all that jazz. It makes sense, but like practically engineering wise, it's always in liters or gallons. So I do get that. It does take time to understand. Kilograms are different, liters are different. Liquid hydrogen is 100% useless. So let's come to the part that people should understand is the wastage. Energy cannot be created nor destroyed. Every Tom, Dick and Harry understands that. Energy wastage, meaning if you have an ecosystem that is wasting energy, there is a penalty for that. You cannot just like, lol, I'm wasting energy. Like fundamentally, our global warming would have been shifted at least 2-3 centuries if our combustion engines were like, let's say, 90% efficient. Like we would not even worry about global warming, simply because we would be consuming so little fuel. Be mindful, always there is always a penalty. For example, people have this separation of calculations where they're like, if I'm paying from solar, who cares? Again, you have to buy more solar panels, you have to buy more wind farms. Those things are cost that you have to bear. For example, you take water, again, you have to have pure distilled water. That itself is very expensive. And again, how the heck this world has enough of it? Like we have drinking water shortage and this guy is like, hydrogen, man. Okay, assume somehow you can drain a river and you have like distilled water. Okay, what after that? You run it through electrolysis. That waste, at best case scenario, 20% of it, meaning the energy 1 megawatt you put in, 20 megawatt, basically 20% of it, heat, you wasted it as a heat. Realistically, you will waste around 30% of it. Then you take that hydrogen. At this point in time, you just have hydrogen. It's 100% useless. So you have to take that hydrogen, compress that puppy to 700 bar. That will take certain percentage of it. You eat it. Now you have to cool that hydrogen. Now, why the heck you have to cool? Because be mindful. You take any tank, it will have some gas pressure. You push 700 bar into it, it will heat up. So for that reason, they have to cool it. Not cryogenically cool it, but they have to cool it. Hydrogen refilling still will have some cooling structure where they're like, let's cool it. No, how much? That depends on how much bars and how much cycle uses and what is the ambient temperature, but there has to be some cooling. That will take a little bit of energy. But again, if they don't do it, the cooling has to be in the car. It's ill-advisable to put it there. Again, weight penalty. So they're like, let's put it in the station so the tank does not overheat. Then that's how much energy you wasted. And again, I'm not even talking about transportation. That a lot of energy just wasted. Basically, you will be very lucky if you have around 75% of energy. 75 is also too optimistic. 60% of the energy before you even reach the car. Well, now you reach the car, again, hydrogen does not mean hydrogen propulsion. It's not electricity. Hydrogen has to be converted into basically electricity. And be mindful, it wastes heat. Like there is a lot of heat coming out of it. Why do you think it has water vapor as exhaust? Water takes a lot of energy to, basically boil off. So it does take a lot of thermal wastage energy. You're talking at least 20% energy wasted. Now you have energy that goes into your battery. Now you have energy that goes from battery to motor driver to motor. Now your car actually moves. So best case scenario, you can be throwing away 50% of all your power. Basically, you put 100 megawatt in, your cars only get 50 megawatt of useful power. Electric vehicle, on the other hand, 90% efficiency in real world. Hydrogen, best case scenario, is not even close to that. And you have to pay for it. Even if it's like, oh, hydrogen is this, hydrogen is that, you have to pay for it. You have to pay for the solar farm, you have to pay for the wind farm, or whatever. You just have to pay for it. It's not going to be cheap. And that's why Mariah did not sell that many. It's like people started to buy it and then they went to the hydrogen filling station. It's like, whoa, it would be cheaper for me to use fuel. And again, early days, that was due. Now fuel prices went up, so it's equalized. So solar farm, wind farm, they are not cheap. People are bitching about those things, and somehow you're gonna waste energy. It's like, what the hell are you smoking? Now you may be like, okay, who the hell am I? Right? I'm an artist. So why the heck I am talking about this and engineers are not? Here's the deal. This is one thing. I even talked about this when we are talking about hyperloop brain damage. Is that whenever you have this sort of thing, there is a very good chance you have to understand that people are people. Meaning an engineer's job is, bro, bring bread to home. He may have a wife, he may have a kid, where it's like, bro, my first responsibility is them. What does that mean? That simply means if their company, for example, Boeing, is like, build me a hydrogen jet engine, they're not going to question. It's like, would you pay me? You will pay me? Okay, I don't care whether it's stupid or not. They know better than me. For example, when NASA was building space shuttle, they knew, the engineers working on it, they knew this is a dumb idea. They knew better than anyone else. Anybody outside, 100 bad things. Inside, yeah, 1000 bad things. Then why did they do it? Again, they had to pay their bills. Or they may be like, dude, so like there could be some governmental issues. For example, ICE engine bans, meaning we could get far less carbon pollution, like far less actual carbon dioxide put into the atmosphere if we improve our internal combustion engine. Then why the heck nobody is doing it? Again, every government is yelling, it's like, we're gonna ban it. So that puts them in an awkward situation where they know this will not work. But again, you are placing a ban on them, then it's like, at least let me try have something, or maybe put hope on some future technology, maybe, have something. So that's why all the engineers working on this, they know better than me. I'll give you 100 problems, they will give you 10,000 problems. It's just that many of them are working like, bro, I get a paycheck, I work, I don't care about it. Or many others like, dude, government is gonna ban in combustion engine or hydrocarbon fuel. What the hell I can do? I get it. Again, I don't have ill wills towards them, but you have to understand it. That's why I do not say that, oh, the engineers are doing it. It's like, again, if they're getting paid, they will work on Hyperloop, even though it's brain damage. They will work on it, and then at the end, it's like, it did not really work. Who would have thought? So be mindful of that. And why the heck we are not aware of it? Well, it's out of sight, out of mind logic. Meaning, if you don't see it, it's not a problem. For example, electric cars, they're combusting a lot of fuel. So we don't see it. It's like, it's the coal power station. It's somewhere out of the sight. So we don't think too much about it. So that's the whole reason. Out of sight, out of mind. Meaning, yeah, you will pay much more for your hydrogen system. But again, if it's subsidized, you will not notice it because it's coming from your taxes. Your taxes will go up, but you will blame taxes, but you will not be able to put two and two together. It's like, oh, taxes are high because they have to subsidize a lot in basically this brain damage. That's the whole thing. For example, this is a Airbus A380, which they are working. I provided a video down below. They are working on making it as a test bed for hydrogen engine. Now, here's this plane has 4 engines. This plane is designed with enough redundancy that even this puppy can safely land on 1 engine, travel on 2 engines. At 3 engines, it won't even report a problem. It's like, bro, some things happen, maintenance, blah, 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 don't even worry about it. Like, captain will not even inform you if one engine, misbehaves. Again, if it goes boom or catches on fire, that's a different thing. But something minor happens, it's like, who cares? It can safely land. It's designed that way. I find it so odd. It's like, instead of compromising one of that engine, why the heck they are using tiny engine? And that engine is tiny. It's not even for basically small 1 aisle aircraft. This is like private jet kind of class, like very tiny. And then it hit me. It's like, yeah, it's running on liquid hydrogen. And those tanks, like they have tanks that are like 100 kilograms. Be mindful, if they were trying high pressure hydrogen, the tanks will be heavy. If they have to use liquid hydrogen tanks in order to keep the weight down. And be mindful, liquid hydrogen likes to boil off. That's why they have a vent that boils it off continuously, because be mindful, God help the airport authority, meaning airport authority continuously needs to refill liquid hydrogen, because again, hydrogen boils off. Again, it's almost close to absolute zero freezing temperature, meaning liquid nitrogen can be kept for a very long time. Oxygen, a little bit longer, or same time as that. Hydrogen, good, God help you. Like, even NASA could not figure out, like, I'm going to fuel it and going to stay it. No, you fuel it, you launch it. It boils off otherwise. So they have to use basically liquid hydrogen, which, mind you, does not have enough oomph. And be mindful, jet engines are very efficient. They do not have same efficiency trap as combustion engine. So they do work a bit more efficiently. At that point in time, this will simply not have enough range. If they tried directly this tiny tanks to pump into the jumbo jet engines, jumbo jet engine will like, whoosh, done. If you had that much jet fuel, it's like, I got this. I can give you some good range on that. That's the problem. Like, they know it. Again, I have provided a video on that. And the place that they are compromising for that tiny engine, if they did that, it would be like, 20 passenger jet will barely carry 5 passengers. Majority of the place will be consumed by the fuel tank. That's why I watched that video. They know it better than I do. Like, for example, this is LNG carrier. Right now, the backbone of this world. Right now, what we do is, like, we have boil off on these tanks. Boil off is collected. That's how this engine is driven. Okay? That's awesome. Done. If it was hydrogen, bye-bye 1 tank. That's the difference between energy density. Meaning, you will simply like, what happened to that 1 tank? Oh, sir, we consumed it. What the hell? Low density. That's why, like, such a giant plane, such high capacity, and you are testing a tiny engine. I'm like, I get it now. I get it. And be mindful, we tried liquid hydrogen planes very long ago. Very, very long ago. And again, they are worried about ban. If government just bans it, they have to do this. They know better than I do. It's like, this will not work. So is there an alternative, like is there an actual way of solving this problem? Thankfully, yes. I cannot just tell you like this is the bad, like what is good then? It's like telling you like, hey, Red Cinema camera is ripping their customer by giving cheap SSD. Is there a better company that is doing a better job? Yeah, it's like Affinity. That's how, like I have to give you options. So is there any actual true solution to this problem? Like where I can have my jumbo jet, I can have my trucks, I can have my locomotives without contaminating the one planet that I live in? Yes, it's basically seaweed biofuel. Now, is the best alternative given all the data set, all the constraint of real world with economic constraint added to mind. Now, why it can be done and no other thing can be done? Well, it does not require infrastructure change. For example, this is a normal plane, but you notice there is a tiny stamp. That tiny stamp is biofuel powered. It does not make a difference. If you make hydrocarbon, it does not matter where it's been made. It does not matter it's made from crude oil by some processes. It does not matter if it's made by plant biomatter. It does not make a difference at all. It's like saying there is a difference between poop methane and methane that you get out of the ground. No, it's the same. CH4 is CH4. So no changes on engine. Of course, they will have like some backup procedures, some just as a safety excess of caution, but inherently you should not need to, because if you have JP1, you have JP1. That's it. Like engines are on. Be mindful. Many of them have tried running on seaweed. Many of them have tried running on algae. Many of them have tried to running on Jatropha plants. Many have done everything, and it's like nobody even cares. It's like that's how common it is. No infrastructure change, no supply change, and how the heck it works on a base level? It works on solar energy. Then it converts that solar energy to chemical energy and it becomes carbon neutral. What does that mean? That simply means it's working exactly like how our bio ecosystem works. For example, you eat food. You take food, you eat it. What does your gut does? It burns it. Then you exhaust carbon dioxide. Now that carbon dioxide is consumed by the next crop that you plant. So carbon cycles, meaning there is no addition or subtraction of carbon. Carbon is there. It has to be there. Everything is calm. Everything is normal. It's just cycling. And what you are actually consuming is basically solar energy. Nothing else. It's exactly the same process scaled upon large unit, and you are running your jets on that. You do not add carbon dioxide to it. Basically, it's exactly how our forefathers envisioned the start of technology. For example, Henry Ford, how the heck he envisioned it. Ethanol was his core value, they banned it. And then Rudolf Diesel, again, ethanol is not that great of a fuel, but again, a good start, an amazing Mark 1 start. Rudolf Diesel comes along, he's like, good start, let's make it better. He uses high compression fuel using vegetable oil. Rudolf diesel engine runs on vegetable oil. That's the reason why they run it. It's like there was no diesel. Vegetable oil was the primary fuel. After his death, they named basically product into diesel. So you have to understand, it's done. Like all our forefathers, they laid a very good foundation. It's like use biology to do that. Again, they had different reasons. For example, one of them had a reason that I do not want oil companies to control it. Other had reason is like, dude, it's self-sustaining. We do not have to worry about it. Again, Mark 1 product, they were limited by their population size. If you increase the population, will that work? No. But the logic will work? Absolutely. Why? Because again, sea has more than enough surface area. Even if you compromise 1,000 square kilometer of it, nobody would even notice it. How do I know? When was the last time you gave a damn about Pacific garbage patch? So that's the reality. Now, why the heck nobody is doing it? Well, it does have one tiny thing that you have to understand. Not on jet engines, because be mindful, jet engines on running on hydrogen, they have to direct burn it. They do not have any technology where you can like take it, convert it into fuel cell, then have magic motors that is high power enough and lightweight enough. Be mindful, there are motors, but those are superconducting motors. Superconducting motors on planes, no. So again, unless you do, and if you do that, again, it will be far more wasteful. So direct drive systems, basically they have to combust it. That does have NOx emission. Very little, but does have NOx emission. Biofuel there does not make any difference. Biofuel on road, for example, let's say truck, yes, you will have emissions, but that's not that big of a deal. And not to mention, if you look at our emission standard of combustion engine, it has become drastically better year over year over year. Like decade after decade, compare decade after decade, it's like, wow, like our current engines, the ppm that comes out of it, basically contamination per parts per million, is very low. It's like, damn, like if you have went 20 years ago and told a car engineer of that time, it's like, bro, we're gonna have that sort of output. They're like, dude, what are you smoking? That's unachievable. We have it now. And I'm damn sure our engineers can do even fine job in future. So it does have that tiny glitch. Again, CO2 is main emission, not the tiny dust particles. Again, we are also reducing it. But the biggest issue is that it's not sexy. Any of you are old enough, let's say in your 30s, you must have remembered the early 2005 to 2010. And this time, solar panels were becoming the big thing. Everybody was like doing the same bitching they are doing with this. It's like, oh, it's not cheap enough. Solar panels would be amazing if it was not cheap enough. Yes, deal. Anything that has good a foundation becomes cheap over time. Mobile phones were not cheap. They had good a foundation. They had a useful tool. They did amazing things. They became cheap because of mass production. Same with solar panel. They had good foundation, sun, energy, everybody needs it. Brick by brick, day by day, it became more efficient, more wise, more logical structures were made, more improvements in inverters were made. Voila, solar is now cheaper than coal, and everybody is still bitching about it. They were like, wind is amazing only if it was cheaper. It's now cheaper. Per megawatt is fundamentally cheaper. People are still bitching about it. Only if we had the technology to transmit power long distances. HVDC was there, but it was very expensive. Now it's cheap, but we are still bitching. It's like we humans have this internal damage inside ourselves that we have to have new things. It's like, dude, we have solved global warming in 1985 or like 2010 if you really want to stretch it. Like, we solved it. It's just that we don't have that sex appeal. It's like, oh, like my plane will not look different compared to what it is now. I'm not going to solve it. It's like, do you want to solve the problem or do you want to bitch about it? Like, that's the reality of it. It's like, it's not sexy. That's why nobody is doing it. Because again, all you have to pay is large sea surface area. You do not have to tamper with your electric grid. Nothing will change. Like, nobody will lose their job. No major issues will happen, and emissions over time will go down. And there are some simple options where you can drop emissions drastically if you have what we call serial hybrid, meaning you have engine, drive a generator out of it, dump that energy into battery, then drive by a battery. Why? Again, engines have very high emissions because they have to work on very high RPM ranges, meaning going wing, that creates a lot of emission. Drop that to fixed system, emissions go down drastically, and mileage also goes up. So there are solutions of that. So what about sacrificing large surface area? Again, you will sacrifice it one way or the other, like mining industries that contaminates our drinking water, or like, wind farms, again, they will also take on sea. So one way or the other, you have to compromise it. So do that. And the only way we can make it long term, like not mess it up again, is basically biomonitoring, because again, it is a bioorganism, we have to understand it. Eco-cycling, meaning right now what we do, algae farming that we are doing, a lot of seaweed farming that we are doing, it's not very sustainable because we are extracting it and that's it. We are just extracting all out of it because again, it's a very big industry for food and medicine. So what we have to do for fuel's sake is basically do the same thing, extract as much hydrocarbon as we can, and then dump everything back in the sea. Because again, sea needs to cycle it. Eco-cycling has to be there, otherwise we have to keep artificial fertilizer. Again, that's why I said foundation is solid there, mass production will reduce the cost. And then the restraint part, meaning we do not have to have that temptation. It's like, we are making fuel, we have this byproduct, let's sell it to drug companies, they're gonna give us a lot of money. It's like the moment we do that, the fuel price will go up. And everybody's like, it's expensive. Everything is expensive. Remember the solars? Solar used to be like idiotic, and that's like 10 years ago. I'm not even talking 500 years ago. That's 10 years ago. Mobile phone, remember 30 years ago how expensive they were? 30, not even like 100 years ago, 30 years ago. So it's like, if the foundation is solid, it will come down in price. You start to do it, it was like, oh, somebody will figure out, oh, other company will figure out this, other people will figure out this, voila. And it will allow us to save our jumbo jets, meaning no changes, no compromise, no new research. By 2035, we'll have this like, bro, we have it today. Trucking industry, no changes. Locomotive, no changes. Nothing changes. Oh, it also removes microplastic from the sea as an added booster. So what we can expect in the future? Well, the reality is I'm kind of losing hope in humanity simply because everything that I'm talking about, like hydrogen part, that has been known as 1950s. Like, people actually were serious. People were figuring out liquid hydrogen. We figured out very long ago. It's like, it does not work. And 1973 was a very important year because oil crisis happened. Basically, this happened to USA. And at that point in time, the president in USA was a very wise individual. He was like, let's use this, not this. So in those sort of time, he was like, okay, let's find out an alternative. Back in there, they went back to the roots. They figured out biofuels. They are like, unfortunately, they created bad fuel, which was like ethanol. They went to sugarcane. Bad approach. And by the time they were creating Mark II fuels, that was algae fuel, they created a conflict of interest between these two parties. They're like, farmers were angry. It's like, dude, we compromised our land for your fuel. Now you're saying we're gonna get fuel from somewhere else. And again, they still realize that population is growing, our demand is growing, it will not sustain us. So final format of that fuel, biofuel, is seaweed biofuel, because we do not run out of surface area for sea nor water. Algae is the best, highest density you can get, basically how many gallons you can get per day. It's very high, but again, we cannot do it because it needs ludicrously large amount of fresh water, because be mindful, hydrocarbon, you will consume water there. It's not cycling there. You're going to consume it. So it has to be done in sea. So that was the final result. We have done that. So it was done. And we give you a better real world example. Rocket industry abandoned hydrogen brick by brick. For example, all the modern rockets that are being worked on, none of them have hydrogen as a core stage. They realize it's like, dude, it just does not work. You can make SLS, it's just a money burning machine. You can try it, it's just a bad idea. You can try Apollo mission, for example, when it had fuel cell system. Compare it to Orion of today. What does it have? It has batteries and it has solar panels. Why? Far more efficient system. Far more efficient. Fire, just shut up and take my money. That's how efficient it is. Rocket engines, all of them realize it's just, even the specific impulse that it gives is just not worth the cost and the hassle. That's the rocket industry realizing that hydrogen, that megajoule per kilogram does not translate as well as you would think it does. So even that hydrogen part is like, no. And that's why, like, how the heck Saturn V could actually get off the ground? Because it was using kerosene, which is basically JP1, a refined version of that. So that's the whole point. And how the heck our leaders can afford to do that? Again, they are burning your tax. They're like, I'm going to give you hydrogen. I'm just going to take a giant chunk of money. And again, if they do not increase your taxes, they will cut other things. For example, generally infrastructure, or let's say education or medical infrastructure. Those things they will cut. So it's your money. They're setting it on fire. And again, I genuinely am worried. I'm noticing that many of these so-called ministers or bureaucrats somehow are angel investors. That's a very dangerous thing. And that comes back to the engineer is afraid part. It's like they are saying to companies, work on hydrogen. It's like, why? It's like, I'm going to invest on you. It's like, okay, sir, but why? Hydrogen is not good. I'm going to ban combustion engines. Huh. Now it makes sense. Like, I'm genuinely scared of that. It's like these bureaucrats can actually destroy a whole country and then just run away with the money. Ask Pakistan. So you have to understand, leaders will just burn your money if you are not wise enough. And you will suffer high cost, meaning, for example, this is a normal plane experience today. You put fuel in the wings. You cannot do that with hydrogen. Liquid hydrogen, hell no. Pressurized hydrogen, heck no. And be mindful, it's like, why the heck you can't do that? Ask rocket engineers how much insulation it takes to store there. And be mindful, jet propellants are stable enough for hours. Liquid hydrogen, no. So they have to be on the bottom. The tanks have to be in bottom. And not to mention, that is the place where we store luggage. So luggage extra cost will become exponentially extra cost. You will be the one suffering for it. Hydrogen, trains. It's like, you do know, we know how to make electric trains for 1 century. It's like, just bite the bullet, spend the money on electric system. Or don't bother with hydrogen. Because again, that energy wastage that you are doing compared to, let's say, a battery system for short duration, over time it will pile up to a point where it's like, wouldn't it have been cheaper if I just took a loan and do an electric railway system? It's like, it would have been cheaper. Or even better, do seaweed biofuel, run it on diesel. You will not have carbon emission, you will not have idiotically expensive parts, and not to mention, you will, like, after 20, again, day 1 it looks cheap, day 25 it looks, not that as amazing. Year 500 is too far basically. Year 3 you will be like, why the heck it is requiring so many maintenance? Yeah, so many things, more maintenance. Like, that's why we love diesel. It's like very efficient, like simple, elegant. Like, you can have a diesel train without single microprocessor. So that's the future. We're going to suffer a very serious rise in cost. And at that point, somebody's going to wonder, it's like, why the heck my hydrogen car is more expensive to run than petrol of the old days? And they will say it's about environment. No, it's about stupidity. And that's why I personally urge you, take a dynamite. The moment somebody says hydrogen has megajoule per kilogram, put it on them and say, I'm going to detonate it unless you tell me how much megajoule it has per liter. That's why you will suffer for it. I will also, but I don't have wife or kids, so I don't have to worry for long term. So this was my presentation on basically hydrogen tragedy, or this curse that's failing to die. Hopefully you have liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.